In 1.1, primary trig ratios. So the opposite side and adjacent side of a right triangle are named relative to the angle being considered. Okay, so first we have to identify the angle, and then we can go ahead and name opposite and adjacent. So the opposite side is across from the angle being considered. Okay, opposite is across. And this is the side that does not form one of the arms of the angle being considered. And I'll show you what that means. So basically, you're able to draw an arrow through this side from the relative angle. The adjacent side is the side that forms one of the arms of like the angle being considered, so the relative angle, but it's not the hypotenuse. And we all know the word hypotenuse. This comes from grade 7, grade 8. This is the longest side of a right angle triangle. It's also the side opposite to the right angle. So, example 1. Name and label all sides of the following triangles using, these are the three: opposite, adjacent, and hypotenuse. So in number 1, we're going to use relative to angle A. So if this is angle A, the side opposite, you can put an arrow through. So this is opposite. Okay, when we're coming from angle A, we're not able to put an arrow through this side because these two sides here make up angle A. Okay, so the adjacent and the opposite meet at 90 degrees. So this is adjacent. And the hypotenuse is always the longest side in the triangle and is also opposite the 90 degrees. Now, number 2, we're going to do this relative to angle C. Okay, so angle C is here. The hypotenuse is never going to change. It's always going to be opposite the 90-degree angle. Now for C, the opposite side is going to be AB, right? It's the side that we can put an arrow through. And the adjacent side is going to be here, BC. The adjacent side is the other side, so hypotenuse and adjacent will make up that angle. So we're going to recall trig ratios of acute angles. Okay, so we're going to use SOHCAHTOA. So I write SOHCAHTOA like this. You can also write it like this. I personally write it this way when it's on my page because it's a good visual of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, so whenever we have a right angle triangle, we're able to use trig ratios, so SOHCAHTOA, as long as we have 2 values. Okay, so here's a note. The opposite and adjacent side depend on the angle being used. Okay, if we're using, say, for example, this angle X or this angle Y, the opposite and the adjacent are going to change. And we always need to find the opposite and the adjacent relative to that angle being used. Again, the hypotenuse is never going to change. So our 3 formulas are sine theta equals, and theta, this is called theta, and this is just an angle. Okay, so sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite or over adjacent. Okay, to solve for an angle, this is just a recap. Okay, we must use sine inverse, cos inverse, or tan inverse, depending on if we're obviously using sine, cos, or tan. Okay, in order to isolate the variable, and this variable in order to isolate the angle. Okay, so I always write SOHCAHTOA on the top of my paper. SOHCAHTOA. I always write that so I can visualize it. So let's start example 2. Find the measure of angle A. So we actually want to find this angle. So the first thing we have to do is we have to label opposite, adjacent, and hypotenuse. So this side is opposite. We can put an arrow through it. The 9 is adjacent because it meets the opposite at 90 degrees. And this 15 is the hypotenuse because we can put an arrow. It's going to be opposite the 90-degree angle. Okay, so when I assess this and I'm thinking about, am I going to use sine, cos, or tan? What I think about are the two sides that I'm dealing with. So I have 9, which is adjacent. Okay, so already I'm not going to be using sine because only cos and tan have adjacent in them. Now, I also have 15, which is the hypotenuse. So I'm not going to be using tan because only cos has hypotenuse. So I'm going to be using cos theta equals opposite over hypotenuse. Okay, this is the general form of the equation. Now, our theta is our angle. We know that we're trying to find angle A. So I can substitute in angle A. So cos A equals, and I'm left with opposite over hypotenuse. Oh, I'm sorry. I wrote opposite. I mean adjacent. My mistake. I actually looked down here and I'm like, oh, there's no number. Okay, adjacent over hypotenuse. So adjacent is 9, hypotenuse is 15. So if you do 9 divided by 15 in your calculator, we get cos A equals 0.6. Okay. So at this point, we are not done. Obviously, this angle is not 0.6 degrees. We need to get the A by itself. And this is when this little cheat, this little note up here, comes into place. In order to get rid of cos, we need to cos inverse both sides. So the cos and the cos inverse cancel out, and we're left with A equals, I mean, if you want to rewrite it, you can say, okay, we're writing cos inverse in our calculators, cos inverse 0.6, which gives us 53 degrees. Okay, example 3, find the measure of QR. So QR is here, let's call this QR. So the angle that we're dealing with is 40 degrees. Let's label opposite, which is QR, adjacent, which meets the opposite at 90 degrees, and hypotenuse is opposite the 90-degree angle. Okay, now we're going to take a look at SOHCAHTOA and decide which one are we going to use. So opposite we need in there because we're solving for QR. So we can't use cos. It doesn't have opposite in it. And adjacent we're given 5 as the measurement. So adjacent, can't use sine. We're going to be using tan. It has opposite and it has adjacent. So tan theta equals opposite over adjacent. So I'm going to rewrite this as tan. Instead of theta, I'm going to write 40 degrees, okay, because that's the angle. Opposite, we don't know, so we can write QR. I mean, you can write X, you can write Y, you just name that side, that's fine. And then over adjacent, which is 5. And now from here, we just have to isolate QR. So we're going to use cross multiplication. Remember, these two numbers work on a row, tan 40 and 5. So we can go ahead and bring this 5 all the way to the front. and we're going to get 5 tan 40 equals QR. Okay, so 5 tan 40 is 4.2. And there's no measurement here. There's no centimeters. There's no meters. So I'm going to put 4.2 units as a general form for units. Okay, to solve a triangle means to determine all angles, so obviously there's 3 of them, and all sides that are not given. Okay, so example 4 asks us to solve triangle ABC. So essentially what we're going to be looking for is angle A, angle B, and angle C, some of which we have. And we're going to be looking at sides, let's call this AB, BC, and AC. Okay? When you're given a right angle triangle, you're always going to be given 3 pieces of information. You're going to be given 2 pieces of information plus the right angle. So angle B is clearly 90 degrees. Angle A is 47 degrees. And side AC is 30 meters. So these are the 3 that we're looking for here. Okay, when I look at this, the easiest thing to solve for is angle C. We know from the prerequisite skills that angle C, so angles A, B, and C are all going to add up to 180 degrees. So if we took 180 degrees and we subtracted 47 and we subtracted 90 degrees, we're going to get 43 degrees. So angle C is 43 degrees. These will add up to 180. Okay. Now let's solve for side AB. So this is going to be side AB. Okay. Let's use angle 47 since, I'm going to change color, since that's the angle that they give us. Okay. So we're going to use SOHCAHTOA. And let's label side CB is going to be opposite. Side AB is going to be adjacent because opposite and adjacent meet at 90 degrees. And 30 meters is going to be hypotenuse, right? It's opposite the 90-degree angle. So to solve for a side length AB, AB is the adjacent side. So already we're not using sine. They give us hypotenuse here. So we're not using tan, we're going to use cos. So cos theta equals adjacent over hypotenuse. So cos theta, theta is going to be our angle. So we're going to have cos 47. The adjacent is going to be our AB, that's our side. And the hypotenuse is going to be 30. We're going to cross multiply that 30 up. And we can go ahead in our calculators and write 30 cos 47. So we're going to get 20.5. And I'll just transfer this over here, 20.5 meters. All right, BC. You know what? I put CB. Let's call this BC just to be consistent. Okay? Doesn't matter. You can name this CB, BC. Same thing. So, again, we have hypotenuse. So let's write SOHCAHTOA. So we have hypotenuse, so we're not going to be using tan. And BC is opposite. So we're going to be using sine. So sine theta equals opposite over hypotenuse. So writing sine, our theta is 47. Our opposite is BC, and our hypotenuse is 30. And now we do the same thing as we just did. We cross multiply the 30 up, and then we can put 30 sine 47 into our calculators. And we get 21.9. Okay, so we can write 21.9 meters. Okay, example 5, solve triangle PQR. So again, solve means solve for all of the angles, all of the side lengths. So we need to solve for angle P, angle Q, which we actually already know because it's 90 degrees, has that box in the corner. Angle R, we don't know. Then we need to solve for a side PQ, which we know already, that's 3 units. QR, which we don't know. And then PR, which is 5. All right, let's go. Angle P, this is opposite, this is adjacent, and this is hypotenuse. Okay, the labeling does not matter. Sorry, we're solving for angle P. So we need to use adjacent and we need to use hypotenuse. So adjacent and hypotenuse is going to be cos. So cos of P is going to equal, we can write adjacent over hypotenuse, or you can start to skip that step and just write in 3 over 5 immediately. Okay, so 3 over 5 gives us 0.6. So cos P equals 0.6. And in order to get the cos off of the P, we can cos inverse both sides. And we're left with P equals 53 degrees. Now that we have 2 of the angles in the triangle, we can solve for angle R using 180 minus 90 minus 53. So that's a quick one. And we get 37 degrees. And I'm going to pull something out from the past. For QR, this is a right angle triangle. We can actually use Pythagorean's theorem to solve for QR, right? If we have 2 of the side lengths, we can always solve for that third side length using Pythagorean's theorem. So let's call 3A, QR is going to be our B, hypotenuse is always C. So 3 squared plus B squared is going to equal 5 squared. 9 plus B squared equals 25. We're going to bring that 9 over, and we get 25 minus 9, which is 16. Okay? To get the squared off of the B, we have to square root both sides, and we get B equals 4. And these can be expressed as units. Okay? If our units are not given to us, we just write units.